7.2 notes, similar polygons. Okay, in this warm-up, I want you to think about how you could prove that triangle ADB is congruent to triangle CDB. You're given that AC is congruent to BD and that segments AB and BC are congruent. Okay? So the reason we're warming up with a proof here is because we are going to do some triangle similarity proofs in this section. So go ahead, and if you would like to pause the video, you can pause the video, make markings for your givens, and decide by what theorem or postulate you could say that triangle ADB is congruent to triangle CDB. So go ahead and pause the video now if you like. Okay, let's see how you did. So the first marking is that segment AC is perpendicular to segment BD. So I know that angle ADB and CDB are right angles. I know that all right angles are congruent, so I know that those two angles that I just marked are congruent. The next thing I can mark is the given, segment AB is congruent to segment BC. And then the next thing I can mark is that BD is congruent to itself. That's the reflexive property of congruence. So I have two right triangles. I've shown that their hypotenuse are congruent and a leg. So triangle ADB is congruent to triangle CDB by hypotenuse leg, or HL. Alright, similar figures. Similarity in geometry means that the figure has the same shape but not necessarily the same size. The symbol for similar is right there, that squiggly mark. It's the part on the top of the congruent symbol that's not the equal sign, so you can think of it that way. Similar polygons are a couple things need to be true in order for polygons to be similar. First, all pairs of corresponding angles need to be congruent. Secondly, the lengths of all the corresponding sides need to be proportional. If you take a look at figure ABCD and figure EFGH, we would say that ABCD is similar to EFGH. By the way, that is called a similarity statement, what's written there at the bottom right. And the reason we know they're similar, angle A corresponds to angle E, angle B corresponds to F, angle C corresponds to G, and angle D corresponds to H, and those are marked as congruent, so we're good there. And then corresponding sides, I see AB corresponds to EF, that's 4:2, which is in proportion with BC to FG, 2:1, which is in proportion with AD to EH, 6:3. So they are similar because all the corresponding angles are congruent and all the corresponding sides are in ratio 2:1. Scale factor is the ratio of corresponding linear measurements of two similar figures. So what that means is, like in the last example, the first figure was 2 times bigger than the first figure because the sides were in proportion 2:1. So that's what we call scale factor. Here, we're given that triangle ABC is similar to triangle XYZ. So what we need to do is figure out, okay, what's the scale factor? So we, again, compare corresponding sides. So 15:6 needs to equal 20:8, which needs to equal 25:10. So that's an extended proportion for the corresponding sides. If we reduce all of those, we get 5:2. So we do know that these are similar, and then the simplified fraction of the ratio of the corresponding sides is the scale factor. So since the similarity statement said bigger triangle is similar to smaller triangle, then we also need to state the scale factor that way. So we need to state the bigger number first, the smaller number second. So we say that the ratio is, or the scale factor is 5:2. All right, so we're going to take a look at a couple figures. We have a similarity statement, and we're going to first start by making sure all the angles are congruent. So if triangle MNP is similar to triangle SRT, what are the pairs of congruent angles? Well, angle M is congruent to S, angle N is congruent to R, and angle P is congruent to T. What is the extended proportion for the ratios of the corresponding sides? Well, we don't have any lengths, but we can list the lengths as the sides. So the length of segment MN we just say is MN. So MN to SR equals NP to RT equals MP to ST. Alright, so let's see if you can try one here on your own. For the next example, you don't have two figures, but you do have a similarity statement, which is all you need. We talked about in the previous section how order matters with similarity statements. So you know that which vertices correspond to which vertices, therefore you know which angles are congruent and which side lengths correspond. So if you want to pause the video here, you can, and do number 1, A and B. Okay, let's see how you did. The pair of congruent angles, F is congruent to K, G is congruent to L, D is congruent to H, and E is congruent to K. Those are all our pairs of congruent angles. And then B, there we have all the corresponding sides. DE corresponds to HJ, EF corresponds to JK, FG to KL, and DG to HL. Alright, now we want to determine if two polygons are similar. So remember, two things have to be true. All pairs of corresponding angles have to be congruent, and all the sides need to be proportional. If that's true, then we're going to write a similarity statement and give the scale factor. So first step, are all the angles congruent? Yeah, if you look at the two figures, all the angles have the appropriate markings to show us that corresponding angles are congruent. Next, we're going to compare the ratio of the corresponding sides. When I do that, I get 12 to 6 is not equal to 24 over 16, which is not equal to 24 over 14, which is not equal to 6 over 6. So there is no common ratio. These corresponding sides are not in proportion, so we say that these two figures are not similar. If you would like to try number 2 on your own, you can pause the video now. Alright, let's see how you did. Number 2, are the polygons similar? If they are, you're going to write a similarity statement and give the scale factor. So for the first one, it's a little bit tricky because the first figure and the second figure aren't positioned the same way. So you kind of have to, in your mind, visually turn one of them to match up corresponding sides. 15 corresponds to 20 and 10 to 15. When you reduce those fractions, you get 3/4 and 2/3, which are not equal. So those are not similar. B, if we look at all the angles first, angles match up, so let's check congruent corresponding sides. We get 12 to 6 and 18 to 9. Both of those reduce to 2, so we know that they are in proportion, so we could say that ABCDE is similar to UVRST. Alright, so now let's use let's talk about ABCD being similar to EFGD and then find the value of X. So we want to set up a proportion here. So I would go maybe long side to short side, talking about corresponding sides, so 9 to 6. That's segment AD, which corresponds to ED, over segment BC 7.5, or I'm sorry, equals 7.5 segment BC over segment FG, which is X. And then we just do our cross product property. So 9 times X is 9X, and 6 times 7.5 is 45. So 9X equals 45. We're going to divide both sides by 9 and get X equals 5. There's also enough information here to solve for Y, so the question's not asking us to do that, but if we wanted to, we could. Alright, your class is making a rectangular poster for a rally. The poster's design is 6 inches high by 10 inches wide. The space allowed for the poster is 4 feet high by 8 feet wide. What are the dimensions of the largest poster that will fit in the space? So, of course, we're talking about blowing up a picture so that the image on the small version doesn't get distorted when we make it poster size. The space on the wall we have to hang this is 4 feet by 8 feet wide. So I like to draw pictures whenever we're dealing with these types of word problems. So we have our picture at 6 inches by 10 inches, and we have a space on a wall that's 4 feet by 8 feet. We have to decide how big we can make our poster in order to fit that space. First step is to go ahead and convert feet to inches. So we know that 4 feet is 48 inches and 8 feet is 96 inches. So if I compare the two sides, or compare the length and the width, if I take 48 divided by 6, that's the big space to the small image, that would make the height of the picture 8 times, and that would fit. 96, the width divided by 10 is 9.6, which if I blew up the height, which is 6, if I multiplied that by 9.6, it wouldn't fit in the space. So the most times that the poster can be enlarged is 8 times. So we can set up a proportion to solve this. 6 over 48 equals 10 over x. Cross multiply, divide by 6, and we get x equals 80. So the dimensions for our poster are going to be 48 inches by 80 inches, or 4 feet by 6 2/3 feet. So we're not going to fill the whole space, but that's the largest we can make our image without distorting it. Scale drawing. The diagram shows a scale drawing of the Golden Gate Bridge in San Francisco. The distance between the two towers is the main span. So what is the actual length of the main span of the bridge? If we know that the scale for this drawing is 1 centimeter equals 200 meters, we know that there's 100 centimeters in a meter. So if we know that the length of the main span on the drawing is 6.4 centimeters, then we want to find the length, the actual length of the main span. So there we go, it's 6.4 centimeters. We know that 1 centimeter over 200 meters is our kind of scale factor here, and we're just going to multiply by 6.4, and we know that 6.4 centimeters would represent 1,280 meters. So that's the actual length of the main span across the Golden Gate Bridge. Your homework for 7.2 is on mathexcelforschool.com, due Sunday at midnight.